All right, what's up, guys? In this video, we're going to pick up some calculus here, and we're going to be back talking about convergence of a series, an infinite series. So we're asked to use a convergence test of our choice to determine if the following series converges. So we're given this series here from k is equal to 1 to infinity. We got 1 plus 15 over k, all raised to the k squared. So the choice that you make as it pertains to the convergence test will really depend on what kind of series you're given. For certain series, certain tests are better, and there's a variety of convergence tests to choose from. In this particular case, I'm going to use the root test. I'm not going to use the ratio test because I don't see any factorials in here. And ratio test is generally very good to use if you get to choose the convergence test. In some cases, I mean, obviously there's more convergence tests than just ratio tests and root tests. You know, there's alternating series tests and all that kind of stuff depending on what kind of series it is. But if you were just nailed down to those two options, let's just say you want to pick between those two, well, if you see factorials, it's probably a good idea to use the ratio test because the wonderful cancellation of those factorials occur when you're using the ratio test. In this case, I'm going to use the root test. So if you don't know what the root test is, the root test for convergence, I have videos on that. And I'm not going to get into too much specific about it, just going to kind of run through the problem, so please check out my other videos on that. So for the root test, remember, it's the limit as k goes to infinity. It's going to be the absolute value of a sub k all raised to the 1 over k is equal to L, where L obviously needs to be a finite value. Another way that you can do it is the limit as k goes to infinity, and you could write it as the kth root of the the kth root of the absolute value of a sub k, and that's going to be equal to L. Okay, so let's go ahead and use it and see what we get. But first, before we start, recall that when we use the when we use the root test, recall that if we get a limit that is less than 1, it converges absolutely. I'll just put ABS for absolutely. If we end up getting a limit that happens to be greater than 1, or let's say we get infinity, then we can say that the series diverges. And if the limit is equal to 1, the test is inconclusive, which means you need to use a different test if you end up getting 1. However, if you get 1 for the root test, you're going to get 1 for the ratio test too. So you trying the ratio test is going to basically just result in the same thing. So you have to do something else. Okay, so let's just go ahead and apply it here. So we'll get the limit as k goes to infinity. And it's going to be the absolute value of 1 plus 15 over k. I'm going to put this in parentheses. All raised to the k squared raised to the 1 over k. We'll close it up like that. So this is what you should have. The limit as k goes to infinity. We have the absolute value of 1 plus 15 over k raised to the k squared, all raised to the 1 over k. Now recall that 1 plus 15 over k raised to the k squared is basically going to be positive for k is greater than or equal to 1. So we can actually drop the absolute value bars, and we could do a little bit of simplification as well. So we'll have the limit as k goes to infinity. And essentially what we'll have is 1 plus 15 over k all raised to the k squared, and that's going to be all raised to the 1 over k. So hopefully that makes sense so far how I got there. All right, let's do some simplification to see what we get. So if we do this, we'll get the limit as k goes to infinity. And if we simplify here, what we're going to get is 1 plus 15 over k all raised to the k. And that's the limit we need to take now. Now recall that if I have the limit as k goes to infinity, and let's say I have something like, I don't know, 1 plus a over k, all raised to the k. Recall that that's just going to give me e raised to the whatever that a is. So in our case, if we look at what we have, when we take the limit here, as k goes to infinity for 1 plus 15 over k raised to the k, well, that's just going to end up giving us e to the 15th. Okay, and e to the 15th, we need to see if that's bigger. That's certainly going to be bigger, but we're going to prove it anyway. All you got to do is put in your calculator. So we'll go over here to the calculator, get e raised to the 15th power. And even if you think you know it's bigger or whatever, just plug it in there anyway. I mean, so this is clearly bigger than 1. So e to the 15th happens to be greater than 1. And if we go back to the criteria for the the root test, notice that if we get a limit that happens to be greater than 1, or if we get infinity, then it diverges. And so that's exactly what this series does when we use the root test. So our final answer for this series here, when we use the root test, we can say that the given series will diverge because we end up getting a limit of e raised to the 15th, which is greater than 1. So we say that the given series, diverges by the root test. And that's basically how you do it. So again, the appropriate test to use will depend on the series, and you kind of just have to see what the series is first before I can give you any answers. And this is something to get very comfortable with, because sometimes in your class, your professor will give you an option. They'll say, okay, apply the convergence test that you feel is best in this particular situation. Obviously, you got to apply the correct one. You know, you can't apply the alternating series test to a series that's telescoping. But they may give you a little leeway from here or there in calculus too. When you start learning about this stuff, to be able to choose whatever convergence test that you think works best, as opposed to just stating you got to use the ratio test, you got to use the alternating series test, you got to use telescopic series test. They'll give you a limit on options. So it's good to get some practice with this, and I do have some other videos on it. Okay, so I will see you guys next time, and y'all take care.